In oxyacetylene welding, oxygen and acetylene are mixed together in a blowpipe to produce a very hot flame, hot enough to melt the metal to be joined and the filler rod used to build up the body of the joint. A rule that you'll meet at once is that all acetylene equipment connections have left-hand threads and all oxygen equipment right-hand threads. Just remember the expression right-o. Open the gas supply control valves slowly so that the pressure rises evenly and there's no sudden surge. Too rapid a flow might result in the safety plug blowing. Open the acetylene valve, set the pressure and purge the hose of air. Close the valve, open the oxygen valve. Set the pressure and purge the hose. Close the valve and the equipment is ready. Open the acetylene control and light up. A spark lighter is best. A yellow flame with a smoky fringe means you need more gas, so open up the acetylene control a little more until the flame burns clear. Now open the oxygen control until you have this sort of flame. The inner cone should be rounded at the tip and it'll flicker slightly. This is called a neutral flame, which is correct for the welding of mild steel. Hold the blowpipe so that it's nicely balanced in your hand. And practice feeding the filler rod through your fingers like this. When you can do this smoothly, you're ready for the first exercise. A good way of starting is to learn how to deposit a straight line of weld metal onto a flat plate. The plate is supported over an air gap to dissipate unwanted heat. Don't forget your goggles, even if you wear glasses. The flame is held steady over the plate with the cone about 3 millimeters above the surface. When the area under the flame melts, the heated end of the filler rod is fed into the molten pool. The blowpipe should be at about 60 to 70 degrees to the plate surface and the rod at about 30 to 40 degrees. These angles are important. This is leftward welding. The blowpipe points in the direction of welding and is preceded by the filler rod. The weld should be straight and even in width and height. Steadiness is the key. A steady forward movement of the nozzle, central to the line of weld, with the filler rod feeding regularly into the front edge of the weld pool. If you have to stop for a moment, be careful how you start again. Don't start at the front edge of the crater. This will leave a small depression which will weaken the weld at that point. The right way to restart is to melt the last 2 or 3 ripples of metal and carry on from there as if there'd been no interruption. The end of the weld needs special care or the weld pool will collapse. Like this. To retain control, withdraw the blowpipe for a moment to arrest the build-up of heat. Then reapply the flame and the filler rod as needed to form a smooth, even contour. Well, that's how it should be done. Now let's look at some of the mistakes that might be made. Most of the basic mistakes are being made here. The blowpipe is shaking. Its movement is erratic, probably because it's being held too tightly. The flame is wrongly set and so not giving maximum heat. The rod and flame angles are wrong. The rod, instead of being fed into the pool, is dripping onto relatively cold plate and sticking. The nozzle is not in line with the line of weld, so there's a heavy build-up on one side and the operator is wandering off the straight line. The result is a cold, lumpy deposit with irregular ripples. The simplest joint to start on is a butt weld. This can be done in the vertical position or on the flat. Let's look at the flat position first. The two sheets are supported on a fire brick with a gap between them to allow the flame to reach and fuse the full depth of the metal. With a neutral flame, the sheets are first tacked together about every 40 millimeters for 1.6 millimeter sheet. Both edges must be brought to fusion point simultaneously. Because the weld metal contracts as it cools, the gap is tapered slightly. Here you can see how contraction pulls the sheets together. If you didn't make allowance for this, the sheets would overlap as the tacks cooled. The tacks themselves should be as small as possible and to the full depth of the sheets. When tacking is complete, any slight misalignment is removed by dressing the sheets. They are then bird-winged. This means bending them so that in profile they form a shallow V. This, like the tapering, is to counteract contraction of the weld metal as it cools. It also makes it easier for the flame to melt the full thickness. The welding follows the same rules as the basic exercise. A steady forward movement and a regular feeding of the rod into the pool. The nozzle and the rod central to the line of the joint and the flame cone just clear of the weld pool. When a tack is reached, it's fully remelted and both edges fused into a tranquil pool. Rod and flame angles must stay constant. At the end of the weld, remember, careful control of the flame will avoid a rapid build-up of heat and a collapse of the pool. A good weld is slightly reinforced with a regular bead, an even width, and close-spaced ripples. The underside is well fused with a continuous bead of penetration looking like a separate run of weld metal. Vertical welding is very similar. The sheets are tacked together with the same gap, and the correct angle of nozzle to sheet comes automatically by holding the shank of the blowpipe parallel to the sheets. The welding rod is bent so that the hand is comfortable and away from the heat of the flame, and the end of the rod is kept in line with the line of the weld. The flame must be held central to the weld pool to ensure full penetration. This is what it looks like from the other side, and you must be careful not to close the gap by merely fusing the two edges together. Welding speed is regulated so that you can always see the melting edges ahead of the pool. And at the top edge, the filler rod is fed in smoothly and regularly to give an even, regular bead of reinforcement. Now let's look at some faults. The gap between these sheets is too small, so the metal flows ahead, sealing the gap and preventing full fusion and penetration. This blowpipe is out of line. The flame is directed to one sheet only and is over-melting it. The result? A weld which is out of line with fusion on one side only. Here, the rod is being fed into one side. It sticks, the rhythm is broken, and there's no progression. This flame is too square on, making the melted edges difficult to control. Metal is blown through and the rod can't be applied quickly enough to maintain an even speed, so you get undercutting of the surface and too much penetration. In light metal fabrication, a very common requirement is the corner weld, which you should try next. An outside corner weld can be made without using a filler rod at all. One sheet is held rigid and the other is guided so that the edges meet at the fusion point as the weld progresses. This method of free edge welding gives minimum distortion and a smooth bead of full section. Where more than one edge is to be joined, such as a box section, another way is to tack the edges first. Then, with a blowpipe angle which is not too acute, the flame is applied to both edges at once with a steady forward movement. The tacks hold the edges firmly together so you can avoid making holes or melting one edge deeper than the other. A slight sideways movement of the flame fuses both edges at the same time and gives good control of the weld pool. Fillet welding in the horizontal-vertical position is a little more difficult to master. If you're not careful, you can seriously weaken the parent metal as well as produce a weak weld. The base plate should be supported with an air gap so that the fire brick doesn't conduct the heat away too quickly. The vertical plate is supported while it's tacked in position. The angles of blowpipe and filler rod are different in fillet welding. The blowpipe should be about 70 degrees to the direction of welding and about 50 degrees to the surface of the base plate. The rod 30 degrees to both plate surfaces. The rod is given a slight circular motion. This avoids undercutting of the vertical plate and also distributes the weld metal equally to each leg. Occasionally, the rod is lifted to allow the heat to penetrate to the root of the joint and so give proper root fusion. You can see both plates melting ahead of the crater. There's no undercutting, and the weld ripples are fine and uniform. The most common faults in fillet welding are holding the flame at the wrong angle and too near the vertical plate, which distributes the heat unequally so that you eventually burn a hole. Melting the filler rod before the parent metal so that metal drips onto the base plate where it gets blown into the root and sticks instead of fusing. Too much bead on the base plate with too little leg length on the vertical plate, resulting in undercutting. Most of these difficulties disappear if the job can be done in the flat position. The flame can be directed at the center line all the time and the heat and metal distributed equally. When you've finished welding, close the blowpipe valves, acetylene first. Close the cylinder valve. Release the pressure in the tubing by reopening the blowpipe acetylene valve. Pause to allow pressure to fall and close blowpipe valve. Slacken the regulator pressure adjusting screw to relieve the spring, the diaphragm and the pointer mechanism. Repeat the procedure for oxygen. Open blowpipe valve, pause, close blowpipe valve. Slacken the regulator pressure adjusting screw and the equipment is safe to be left. This is elementary oxyacetylene welding. When you can make butt welds, outside corner welds and fillet welds with confidence, you'll be ready to try some more advanced techniques.